Good afternoon. This is a live demo of test-driven development 101 level for the problem FizzBuzz. So for those of you who are not familiar with FizzBuzz, FizzBuzz is a kids counting game where we write a program that counts from 1 to 100. For multiples of 3, we print fizz. For multiples of 5, we print buzz. For multiples of 3 and 5, we print FizzBuzz. And for all other numbers, we just print the number back as a string. This demonstration is done in C# using the xUnit testing framework. And we're just going to walk step by step through this process. So I've done a little pre-scaffolding work, and the README file will contain all of the information for how to set your environment up. I'm using JetBrains Writer for my development environment and .NET 6.0 on a Mac. I'll try to include links for instructions for using Windows or Unix machines, etc. The README is as yet incomplete. I did this exercise last week in JavaScript, and I was asked to repeat it in C#. So here we are. So I've done some pre-work. I've already set up 2 projects, FizzBuzz and FizzBuzz, or Test FizzBuzz. These projects are empty, and they're within a solution called FizzBuzz. So what we're here to learn or to understand is sort of TDD at the 100 level. Very simple. What you need to understand about TDD is what are the rules of TDD, or how does TDD work? So test-driven development, the intent here is that we drive the implementation we build through creating tests. Within TDD, there is what we call the TDD microcycle, or just the TDD cycle of red, green, and refactor. So the first thing we want to do is write a test, and that test will be failing initially because it can't compile, and secondarily because we haven't written any code to make the test pass. We want to write the simplest test we can write, just enough test to test something, right? Then write just enough code to make that test pass. And we gradually work our way through the problem by writing a test and code that makes it pass. And then we do some cleanup. That's the refactor step. And we repeat that cycle over and over and over again to build up to a solution. So what I'm going to do here is just a live demonstration of doing TDD. I will include some commentary. I have some notes here to remind myself of what to talk about. This shouldn't take long at all. The JavaScript one took about an hour. I think I can do this a little bit faster in C#. We'll see. So the first thing we do is we go to our Test FizzBuzz project. Our Test FizzBuzz project has imported just enough of the frameworks, specifically, where is it? Well, xUnit is imported there so that we can run the tests using the xUnit test runner. So the first thing we're going to do, we'll add a class for our test, and we'll call that Test FizzBuzz. And that'll put that class there. We'll stick that in source control. And within here, we want to use the xUnit marker test. And, well, that's cute. It didn't auto import that. Gotta love this .NET universe. So we're going to start with the simplest possible test case, right? FizzBuzz given 1 returns 1. That's a nice, straightforward, simple test. And a lot of times you're asked, like, well, what's the reasoning behind picking this test? In this case, it's the first requirement. I want a loop from 1 to 100. The first thing in that loop would be 1. Seems like a reasonable place to start. But James Grenning invented the notion of zombies as a mnemonic to remind yourself of what to test, right? So zombie stands for 0, 1, many, boundaries, ZOMBI. I is for interface, E is for exceptions, and S is for standard. So that's a way you can kind of remember what to test. Why are you telling me I don't have this annotation? It's not import. You gotta love it when your brain just spazzes out while you're trying to live stream. At a minimum, it slows down the live stream, and that's annoying. So if you give me just a moment, I will pull my head out of my rear end, and I will remember what I'm supposed to have imported here. I'm wondering if I accidentally uninstalled xUnit while I was preparing this. So xUnit, and sorry, I'm using the wrong keyword. So in xUnit, tests are described by facts and theories, and we're just going to deal with facts. So we place an annotation above the method that says this is a fact. Another way to think of a fact is it's invariant. It must always be true. And what we're trying to do is establish the facts around how our code works. So we're going to start with this, like I said, given 1, return 1. And I'm going to be pretty simplistic about how I go about this. So var given is 1. Oh wait, I'm sorry. Yeah, I'm off my own script. We're going to start with the assertion. We're going to start by saying assert equals 1 result. And the reason that I'm starting here is this is a good way to build up a test, right? If I start with what am I trying to prove, it helps me limit the scope of what I shove into a test, right? So var result, where does that come from, right? Let's say FizzBuzz generator, FizzBuzz for some input value, or given, right? And then I need a given. So I'm going to say given is 1, right? Given 1 returns 1. I could even go so far as to say expected is equal to 1 and place expected down here. So given that given a 1, I expect 1, call FizzBuzz generator, test to see if they match, right? Very straightforward. Now obviously there's a complaint here. FizzBuzz generator, what is that? It doesn't exist. So we need to go create implementation code. There are a couple of different techniques that are used here. One of the techniques is to create this FizzBuzz generator code right here in the test. The other one is to create it in the location it will result in production, in your main line of code. Personally, I prefer the latter to put it into the production code. So that way I know the plumbing works, I don't have to worry about it later, right? So, class, FizzBuzz generator. And you could use your tooling's autocomplete or whatever you want to do to make this quicker or more automatic, but it's not that much typing, right? And then we called that method FizzBuzz for. So we're going to say public string FizzBuzz for given does nothing. Oh, and what is given? Given is an int. We're just going to return an empty string for the moment. And then we need to import this. So I use the auto import by holding Option and hitting Enter, and it just automatically picked the right thing for me. Oh, and I need to make this method static so that it can be called without instantiating the FizzBuzz generator. So there's no need to create a FizzBuzz generator for this demo. Those of you who have heard me rail on static before, yes, I know I just use static, but this is just a toy problem. So apologies if you think I just violated one of my own rules, which is don't use static. Anyway, so we now have our test code. It compiles, so we're past the first red. Now we're going to run it, and our expectation is that it's going to fail. It's going to fail because we didn't write an implementation. It's just going to return an empty string. So first things first, build it. Make sure we got our build chain working. Then we're going to go over here, and we should be able to do run unit test. Yes. So in our pop-up menu, which I don't think you can see, sorry, but when I right-click on FizzBuzz, the solution, there's a run unit tests, which I can also access with Control semicolon comma R, which seems like a lot of keyboard kung fu, so I'll just do it with the menu. So it's compiling. It should run here in a moment. It's possible my build failed. No, my build succeeded. There we go. Needed to poke it a second time. There we go. So xUnit SDK equal exception. Assert equal failure. Expected 1, actually received nothing. That's exactly what we expected. So what's the simplest thing that we could possibly do to make this pass? We could just return 1, and that test case would now pass. And look, it did. So you might be asking, well, like, Rich, that seems dumb. That doesn't do anything very useful. What I'm doing is I'm working my way into a set of test cases that tell me how the system works overall, right? And this gives me the flexibility to sort of inch my way forward in tiny baby steps, right, towards a full working solution. So our next question then is, well, okay, what do you test next? One way to think about the FizzBuzz problem is that for all numbers that aren't divisible by 3 or 5, all we're doing is converting that number into a string. So the next number that isn't divisible by 3 or 5 is 2. Let's go ahead and do public void test FizzBuzz given 2 returns 2. Okay? So that sounds a lot like the previous test, and it is, except that we're going to say given 2 expected 2 result is FizzBuzz generator FizzBuzz for given assert equal expected actual or expected result, right? So very much the same sort of test, right? And these two things comprise essentially rule number 1, which is given a number that isn't divisible by 3 or 5, return that number as a string, right? So here we're creating 2 tests that are going to validate that our source code over here on the right is returning what we anticipated. So I'm going to hit the red go button. I expect this to fail because we don't have a case for 2. We only have a case for 1. And sure enough, it failed. And it failed exactly as we thought it would. Expected 2 actually received 1. We know that this happened because we just said return 1. So what's the simplest thing we could possibly do to get this thing, oops, wrong language. What's the simplest thing we could possibly do to get this next test case to pass without breaking the first one, right? Just call toString on it. No more complicated than that. We'll run again. And look, they both pass. So we're in a good spot around rule number 1 already, right? Basically, we now know, given anything as an input, we're going to convert it to a string and return it. We don't need to write more tests, but if we don't feel comfortable, if we're not sure, there's no harm in writing more tests. But I'm going to take this opportunity, because we're green, to do a little code cleanup. So you notice over here our tests are pretty loud. There's a lot of lines there. Your test code is effectively executable specification for how your system works. You want to keep it clean, and you want to keep it easy to understand. and you want to apply many of the same rules that you would apply to your production source code into your test source code. But one difference would be dry. You may have heard of the acronym DRY, don't repeat yourself. Obviously, this code repeats itself a lot. Line 14 is identical to line 25. Line 27 is identical to line 16. Really, the only difference is these two variables being established on at the beginning of each test. That's pretty noisy. So the temptation might be to extract an execute method or something where we just pass in the given and the expected and walk away, or use one of the xUnit parameterized test functions, which I'll cover in another demonstration, to dry the code out. But what I want is I want my test case to be readable, and I don't want to have to scroll off to some other pile of code somewhere, or have to chase through 3 files. How does this test work? I ideally want my unit test to have everything I need right there in one spot. So, how could we make this a little less chatty and still get the same effect? One trick, or technique, is to inline variables. So there's a command in Writer, Option Command N for inline. I just inlined the expectation here. I can then do the same thing on the result and inline it there. And the same thing for the given. And now I have one line of code, although it's got some funny carriage returns in it, one line of code that represents my test case. Right? And that's a little easier to read. It's a little easier to digest. Right? So I can repeat that here. And that time I didn't put in an extra carriage return. Better finger usage, right? And now I can run those tests. And they're going to pass. Hey, look at that. So now I've established like a nice, concise way to write that test. Another thing about the test is, you might be tempted to redo this test like this, and maybe have more than even 2. You could have 4 or 5 or 6 things. And while that's not invalid necessarily, like it'll still run and pass and give you the test information you wanted, it's hard. If one of these things breaks, it's hard to determine what's broken. Harder. I have to read the stack trace, find the line number, then go in here, find the line number, figure out what that did, make sure nothing above it had any impact on it. It's not isolated. So by keeping these as 2 functions, right, I now know if this one were to break, so let's break this guy, right? If this one were to break, when I execute my tests, that one's going to turn red, and I can double click on it, and it jumps my cursor right to the line, and I know, because there's no other code here, that whatever's wrong is on this line of code. And if I stuck with the previous implementation, I would still know it's within just these couple of lines. There's no side effect coming from some other test, no other interaction. So that's a tactic you can use to keep yourself sane. Similarly, in real complicated problems, right? Setup may be many lines of code, execution may be many lines of code, assertion may be possibly many lines of code. If you start mashing all those things together, it's going to get a little bit crazy. Let me back up a second. I forgot to mention something. Yes, undo document that was modified. You can't see it, but I'm getting little pop-ups telling me that I'm undoing modifications. I forgot this part. And I'm supposed to be doing a 101 thing here, so I may abandon this video and start again. I don't know. Let's talk about the anatomy of the test case, right? Arrange, act, and assert. This is the common terminology. Arrange is the setup. Get this thing ready to go, right? Act or execute. Go do the action. Assert. Also assert on this one, right? Go test, make a check that says this is true or false. Okay? So all tests should follow the form of assert, arrange, act, assert, or setup, execute, assert. Or you will sometimes hear given, when, and then. So, given some condition, when some action occurs, then something should be true. Set up my world, execute my statements, assert that something is true, or arrange, act, and assert. All of those are perfectly valid and normal things that you might hear. And keeping that in mind and using visual white space to separate those things can make your life easier, especially when you're dealing with something significantly more complicated than FizzBuzz. We'll cover that again in later exercises, of course. So going back to my one-liner, right? We've tested rule number 1. Now let's look at rule number 2. So what is rule number 2? For multiples of 3, print fizz instead of the number. Okay, that's rule number 2. Rule 2. Divisible by 3 is fizz. Right? So what's a first reasonable test? Obviously, I think it's obvious anyway. We test for 3, because 3 is definitely divisible by 3. Test FizzBuzz given 3 returns 3, and we say assert. It's the same pattern, right? Equal 3 FizzBuzz generator FizzBuzz for 3, except the expectation is that it will be fizz. Now, we fully expect when we run this test that it's going to fail because we've written no code to support the fizz case. Rule number 2, right? When you're running your tests, right, you should be running your test after every change, and you should expect an outcome. You should expect it to pass. You should expect it to fail. If it doesn't pass, or when you expect it to pass, or it doesn't fail in the way you expected it to fail, take a step back and think about why. Read the stack trace. Look at it closely. Just the other day I was doing this and it failed because I had a typo, a syntax error, and I was like, what the heck, right? Like, I don't understand. That should have passed. And my initial impulse was to go to the wrong place looking for why. I stopped, I looked at the stack trace and went, you have a typo. All right, cool. So given 3 returns 3 failed. Expected fizz got 3. We know why. There isn't much thinking required here. We know exactly why because it's a new test and we haven't written any code for it. So what's the simplest thing that could possibly work here? How about if given is equal to 3, return fizz. Run it. Hey, that passed. Doesn't like my code formatting. I'll do a little format action. So what's the next rule? Next part of that rule? What would be the next thing that we can use to tiny little baby step to get us to completing rule 1? Well, how about the next thing divisible by 3? Some people might suggest trying 4 here, but 4 proves what we've already proven with 1 and 2. Some people might say 5. Well, 5 is the buzz rule, or rule number 3 in the system. Let's not mix the thinking about the rules. Let's focus on this one rule around the number 3, and we'll do public void test FizzBuzz given 6 returns 6, and assert equal FizzBuzz generator FizzBuzz for the numeral 6. Right? It's the same test as last time, but this time for 6. You might ask yourself, well, Rich, why didn't you copy paste that? Pro tip, copy paste usually leads to a mistake. I forget to update the function name. I forget to update one of the variables or arguments. I end up just doing it again. Typing isn't what's slowing me down. Thinking is what's slowing me down. So when I force myself to type, it forces me to think about what I'm doing, not what I've done before. I'm not trying to think about typing efficiency or any of that nonsense. I'm thinking about what problem am I trying to solve. And this actually makes me faster in the long run. So we added this rule, or this test, right? Given 6, I should get fizz. Run it. It's going to fail. I know, oops, I know it's going to fail because I don't have a rule for that. I've only got for 3. Sure enough, this one failed. What's the simplest thing we could possibly do? How about we'll take mod 3 is equal to 0. So when we use the modulo operator, this percent sign, what we're saying is divide given by 3 and give me the remainder, right, of the equation. Well, if it's divisible by 3, the remainder is always 0. So this tells me whatever this number is, it's divisible by 3. So we'll run that, see if it passes. Look at that. So that's rule 2. Do we need to test any other cases? Do we need to test 9, 12, 15? Well, we will actually test 15 later, but we don't need to test 9 and 12. We've tested 2 cases of the number of things divisible by 3. That's enough. All other things divisible by 3 are going to conform to this rule. And we know that because we know that the given value, mod 3, will return 0. So we're done. But if you're not confident, if you can think of a case where you're not really sure, it doesn't hurt you to add another test over here to make sure that you've done it. The old adage is test until you're bored. Test until you're absolutely confident that you're right. That's probably enough. And if it turns out not to be enough, learn from that. Learn from the fact that, you know, last time I wrote 4 test cases and later I found a bug. So maybe I needed a 5th test case or a 6th test case. Pay attention to that stuff. All right, cool. So that was rule number 2. Rule number 3. What's rule number 3? For multiples of 5, print buzz. So basically the same idea. Rule 3. For multiples of 5, print buzz. It's basically the same idea, but for another number, right? So, starting again with what's the simplest test I could possibly write? Let's do public void test FizzBuzz given 5 returns 5. Assert equal buzz this time. FizzBuzz generator FizzBuzz for 5. Okay? So, same pattern, same deal, except we expect buzz, and we expect this test to fail. Why? Haven't written any code for it. But we're going to run it anyway. It's going to fail. You'll get into this rhythm where you just run these things like almost automatically. Like the minute you stop typing, you hit run. And it passes or it fails. And there's no judgment there. Let it fail as many times as it needs to fail. But then when we get to the fail point, we say, okay, given 5 returns 5. Oh, look at Rich making mistakes. These, yeah, I should probably remake this video. Sorry. So I misnamed those other ones because I was talking and not paying attention to what I was typing. Given 3 returns fizz, given 6 returns fizz, given 5 returns buzz. So I fixed those names, right? My bad. But we've gone ahead and we've fixed that now, so we're going to run that again. Those are just name changes. Don't expect it to fail for that. Right? And we see expected buzz actually got 5. So, what's the simplest piece of code we could possibly write to solve that problem? How about if given equals 5, return So you might ask, well, Rich, why aren't you immediately jumping to given mod 5 equals 0, return buzz? Again, this is a trivial case, and I probably could, but I'm taking the smallest step forward. I'm only writing enough code to pass the tests that I've written, and no more, even though it's obvious. I'm just like, all right, don't think ahead, don't try to be clever. This doesn't really save you much time in the FizzBuzz exercise, but it'll save you a lot of time in the future, because in the future, you'll be dealing with something more complicated, and you'll make an assumption. And then it won't work, and you won't know why, and you'll spend a bunch of time trying to figure out what you did. when you could have just said, you know what, I'm going to only write enough code to pass this test and no more code. All right, cool. So we run it again. It's going to pass. What's the next test? Well, in this case, we are following the basic same pattern, right? Public void test FizzBuzz given 10 return, which is the next multiple of 5, returns buzz. Assert. One moment, please. Things are ringing. Stop ringing. So assert equal buzz FizzBuzz generator FizzBuzz for 10, right? And we expect to get buzz. We're going to run that test. It's going to fail. We didn't write any code for this yet. Sure enough, it failed. Test FizzBuzz given 10 returns buzz. It failed. So now we do the obvious thing. Again, trivial problem. We're not really worried about the complexity of our problem in this exercise. We're worried about the mechanics of TDD. Right? So we're going to change that to given mod 5 equals 0, return buzz. We're going to run that. That's going to pass. And that's it for rule 3. So far, so good. Rule 4. For multiples of both 3 and 5, print FizzBuzz. Okay. So, rule 4. Multiples of 3 and 5 return FizzBuzz. You might ask, why am I putting that comment there? Well, honestly, I put these comments here while I'm working on a specific thing to help me focus, and also because if I stop for coffee, when I come back, I've got a comment there that kind of reminds me what I was in the middle of. Effect, public void, test, FizzBuzz given, what's the first multiple? 15. Returns FizzBuzz. Assert equal FizzBuzz FizzBuzz generator. Hey, that's weird. I can see the IntelliSense here, but you can't see half my pop-ups. I don't understand that. Some OBS / Twitch expert can clue me in later. FizzBuzz for 15. So again, simple test case, one line. Expect it to fail. Haven't written any code for this case. Run. All right, and it failed. FizzBuzz for 15 did not return FizzBuzz. It just returned fizz. So we can look at our code and say, well, what happened there? So I got a 15. It was divisible by 3. I returned fizz. So how would I make this work? Where would I put this code? Obviously, I want to put it before this code, right? I could put it after, but the test will fail because it's always going to see this first and return immediately. So I'm going to put this code here. If given is equal to 15, return FizzBuzz. And I'm going to run that. And it's going to pass. Awesome. Same pattern as last time. Do it again. Fact, public, void, test FizzBuzz, given 30, returns FizzBuzz, assert equal FizzBuzz, FizzBuzz generator, FizzBuzz for 30. I'm going to run this and I know it's going to fail, right? It's going to fail because I haven't written any code to make it pass. Look at that, it failed. And it failed for the reasons that we thought, right? There's no code for it, so it fell through to this given mod 3 thing again and said fizz. So how would we make this pass? Well, we would say something like given mod 15 is equal to 0 and given mod, sorry, not mod 15, mod 3 is equal to 0, and given mod 5 is equal to 0, return FizzBuzz. Now those tests should pass, right? Correct, they passed. So we're in a pretty good spot here. I didn't really talk much about checking code in and out. Make sure I'm in the right place. So if I do git status here, you'll see that I have two modified files, FizzBuzz generator and test FizzBuzz. And they're not staged for commit yet. So I'm going to do git commit -a for all, which will take care of the staged, and m for the message, and say basic rules. Okay, so now that's committed to source code. I'm in a green state. My tests are all passing. Now I can do some refactoring. Now I could have started doing this refactoring earlier. Figuring out when to start refactoring is always a challenge. Everybody struggles with, do I refactor after the second test? Do I refactor after the fifth test? The measure I use is when I feel like I've got enough of a solution put together that the refactors aren't going to just get reversed when I do the next step. Now I've done FizzBuzz a few hundred times now, so I kind of have a really good sense of this is a good time. Your mileage may vary. So what could we do to maybe make this code a little less ugly, a little less blah? Well, one thing we could do is this. We could say var result is equal to empty string, and then say result is equal to FizzBuzz, or result is equal to this, or result is equal to this, and then we could say if result not equal to an empty string, return result, otherwise return the given string. Now, is this going to work? No. Why? 15 is going to say, oh, set result to FizzBuzz, and then it's going to say set it to Fizz, and then it's going to set it to Buzz. So if I run this right now, the tests for 15 and 30 are both going to fail, because they're going to say I got Buzz and expected FizzBuzz. I'll prove it to you. We'll run it. Two failing tests. Look at that. FizzBuzz, actual Buzz. FizzBuzz, actual Buzz. We need one more little bit here. If we chain the ifs together, like this, now it works. So because we pulled those returns out, we changed the flow control within the method so that it only returns at the bottom. And as a consequence, all of the ifs got applied. So we had to put those else's in there. So that's a nice step that got us a little closer, but this is still pretty hideous, right? We still have this awful structure where, we have an if, else, if, and then at the end we don't have an else in case none of those things were true. We could do all kinds of stuff, but here's where I'm headed, right? This is, I think, more interesting, right? What if I said, hey, the first rule returns FizzBuzz, the second rule returns Fizz, and the third rule returns Buzz, but the first rule is really the second rule and the third rule together. Okay, what if I did this? Given that it's mod 3, add the word Fizz to the result. Take the else back out and say, given that it's mod 5, add the result there. Run that. Should still pass. Unless I made a mistake. Nope, I didn't make a mistake. It still passes. And the code's a little bit easier to read. Right? This thing is still kind of ugly. Yuck. So this is a case where I would probably use a ternary. I'll be honest with you, I didn't take the time to check into this, but there's probably even a really cool C-sharpism that I'm not thinking to use here. Right? But you could do this, and you could use a ternary operator and say if the result is equal to 0, then turn the given into a string, otherwise return result. That's one way to get there. Made that one simple change, we run it, look at that, works. Another possibility is given to string and take the plus out and then just return result. This would also work, or should also work. Uh-oh, it failed. Buzzy things got the number plus buzz. So let's not do that, right? That's a test. That's a, I tried a thing and it didn't work, and it's easy to undo, right? Because I didn't do very much. So let's leave it like that. That's probably good enough, right? We've got some tests here that now exercise all 4 rules. We've cleaned up this code and made it pretty tight enough, without doing any sort of clever hijinks. And, you know, I would recommend in any code, test code, production code, whatever, clever is the enemy of good. One of our main goals in writing code is to make sure that the person who's coming later can understand what we did. Oftentimes, that person is us. So 6 months from now, I come back and I go, wow, what was I thinking? But this answer, this solution, it's clean enough. We'll do a little formatting. We'll jump back into our terminal window here. We'll do a git status, git commit -a -m, clean up the code a little. Everything's checked in except the README. Like I said at the top of the video, or the top of the stream, I'm gonna clean up the README file. I just haven't had time to do it, but I wanted to get this video produced and out. So, what else can we do? Let's see. We're getting a complete white space, did not insert selected suggestion. I'm okay with that. I'm okay with that. I have an unnecessary import. Any others? No. Run my tests. Okay, cool. So, what's the next part of the FizzBuzz game? Write a program that prints the numbers from 1 to 100. Now, I hope I set this guy up over here as a command line program. Maybe I didn't. But we'll worry about that in a second. Let's write a test. If we write tests first, we always get only the code we need, and it's always got good test coverage. If we write code without writing the test, even if it's declarative, even if it's obvious, right? It's there without a test, and so then that leaves the reader with the question of, should this be here? How should this work? The test, like I said before, that's your executable specification. That tells you whether or not something should exist and how it should work. So let's talk about the game, right? The game is just basically a loop from 1 to 100 run through this FizzBuzz for method. So how could we possibly test that? Well, how about test FizzBuzz returns one for on the first iteration, right? So our assertion is that we're going to get the string 1 from the output of playing the game. So we'll use some array syntax here, right? Output 0. And what is output 0? Well, output 0, or output, right, is output is an array, or a list in our case. I guess we could use an array literal. 100 entries. I've just come to the realization that I don't know how to do this in C#. Give me a second, I'm thinking about it. should have practiced. I think we're going to end up throwing this video away. What time is it? Okay, been at it 45 minutes-ish. So what if I did FizzBuzz generator play so I need a text writer. Watch me do this on the fly. Text writer. Little Google flu time. I think I might be able to use string writer here. All right, so I'm going to test my way through this. Pretty sure this is going to fail. This won't compile, so I'm going to put 2 over there just so we're sure it fails. I'm going to pass writer into FizzBuzz generator. So what code doesn't exist, right? We're in a red state. Can't run this. First thing that doesn't exist is a constructor. So let's go create a constructor that says FizzBuzz generator takes some kind of text writer, and stores it locally. So this writer private text writer, oops, text writer, and then we're going to add our play function, because you can see over here we still have this red squiggler. It says I don't like you because you I don't like you because you don't have a play method. So public void play, and we'll just do something like this writer hello modo, this writer write, and then we'll run our tests. And this last test is going to fail. We know that, right? We're just exploring because Rich forgot to prepare for this step. Okay, cool. So it says, hey, 1 expected 2. So it didn't. One of the things I don't like is where it hides the output from the test. It suppresses it. So what we can do though is we can simply do writer toString there. Assuming that string writer works the way I want it to work, this will be fine. And if it doesn't, I'll abandon this video and make it again. Aha! toString got me a hello modo. Awesome. So what's the simplest amount of code I can write to get this to pass? I can return 1. Hey, look, they all pass. So what about the next thing? So that was like trivial, right? Except for the part where Rich had to remember C# things. Public void test FizzBuzz returns 1. Let's see, returns 23 on the 23rd iteration. And you say, but Rich, how are you going to know you're on the 23rd iteration? Well, we'll get there. New FizzBuzz generator. So 21 is divisible by 3, 22 is not, 23 is not, I think. Pretty sure, yeah. So I should get the string 23 from writer to string. That's not quite perfect, but it's close. First we'll run it, we'll make sure that that plugs through. It does. It says I got a 1, we knew that. Right, because our implementation only returns 1. So how would I get to the 23rd line in the output? Well, one way is to say writer to string split right, and that split should return a string array. We'll call it lines. And then we'll just say, hey, actually I think before we call that output, right? So we'll call it output. Output 22. Remember that arrays start at 0, so the 23rd line is index 22. Right? So we're going to run that. It's going to give us an array index out of bounds error. Look at that, index out of range exception. So what do we need to do to fix that? Well, this might be a bit of a leap, but we're going to do for int idx equals 1, idx less than 100, 101, idx plus plus. That's going to get that first part of rule, this last rule, which says I'm supposed to play the game from 1 to 100, right? Then we'll run that. That's the smallest amount of code I can write without thinking too far ahead. Okay, I got some fails. Right? What happened? Well, first off, I failed the previous test because it is trying to use the whole string. So I'm going to need this same trick with string output. And then I'm going to need this to become output 0, the first line. So I'll run that. Oh, failed on the first iteration, got way too many 1s. What the heck? Oh, those don't have carriage returns in them, so it didn't split. So we'll do right line. Now I get carriage returns, or line separators. Okay, cool. Now, on a Windows box, by the way, and I'll go test this on a Windows box later, you might need to use /r/n as the separator. Otherwise, you'll have some /r's in here that'll mess with you, but I don't have my Windows box handy. So this one's failing because it says I only got a 1. So how would I get this guy to give me something other than 1, to give me the 23rd element in the 23rd position? Well, I would do FizzBuzz for idx. And now I'm going to run that. Hey, look at that. They both passed. Right? They did what I expected them to do. Now, there's still a boundary condition I haven't tested, right? Remember the bee and zombies, which is 100. Fact, public, void, test, FizzBuzz, returns, buzz on the 100th iteration. So 100 is divisible by 5, right? So we should get a buzz, I think. Pretty sure. New FizzBuzz generator. Writer. Play. String. Output equal writer. String, split on new line character, assert equal buzz output. Remember that off by one thing. The 100th iteration is number 99. Awesome, that one passed. I wasn't really surprised, were you? So one more thing that we could do here while we're messing with play. How do I know for sure? How do I know for sure that I only got the numbers 1 through 100? In all of these cases, I've been very specific about what index I want. Well, I could do void test FizzBuzz returns 100 elements, lines, or outputs, whatever word fits here, right? Naming is hard. So text writer equal new string writer new FizzBuzz generator writer play assert equal writer toString split size or length. Sorry, length is 100. So I'm just saying, hey, I didn't get 101 or 103. I got 100 outputs. What happened? Expected 101, actual 100. What did I do? Well, the first thing I did, xUnit wants your expectation first, and so I had those backwards. So I got a weird looking error message. By the way, that's important, right? The frame, understand your framework and understand that the first thing is expected and the second thing is actual. Or if you're in other languages, sometimes it's actual first, expected second. It can impact the way that the error is reported. So here it's saying, hey, I expected 100 and I got 101. Now why would I get 101? Well, it's because it's because the 100th thing had a carriage return, and when I split on carriage return, I'm saying carriage return and I mean new line. Everything has a new line. I split on new line, so it gave me the last element of this array as its own thing. It's empty, right? But it is there. So we'll put a trim in there. That'll take care of that very last carriage return. Sometimes figuring out how to make the assertion is as hard or harder than writing the code itself. So there you have it, right? We've tested all the things. Is there more cleanup we could do? Yeah, potentially we could try to make this prettier, this bit with the string writer. But, you know, it's not that egregious. There's 4 tests here that have a text writer. 3 of those also convert that writer into this string array. What we could do is maybe something like I'm going to use some Kung Fu, right? So Option Command M for extract method, and I'm going to call that method writer to array, given writer, and I'm going to make it static. That's fine. My buddies in C# land, they like their static a lot. But this is just a little helper function that we're going to make for ourselves, and we'll stick it down here at the bottom because we don't really want it cluttering things up. It's got a very explicit name. It says I'm converting a writer to an array, and it takes a text writer specifically and returns a string array. So there shouldn't be a lot of confusion from users playing with that. And then I can take this and replace it in all these other places. And I can run my tests, and they should still pass. Now, here's the thing that's interesting to observe, right? We have these other tests about the 99th element and the 22nd element and the 0th element. But we still have this separate thing here, this separate, turn me into an array. Could we put that trim here? Do all the tests still pass? Because if we could, they do. So if we could, and we can, then we can take this bit out here and change this to writer to array writer. And now life is grand, right? We've gotten this ugly, cluttery, what am I doing here code localized to one spot. So if we were to make any changes over here in the production code and we needed to figure out how to deal with the output in a different way, we would be ready. For example, somebody might want these separated by one line, so now we have to take out twice as many things, or we have to jump over stuff, and this could get complicated. And rather than having it in 4 places, we have it in 1. So this is a case where we are drying out the test a little bit, but not so much so that we have to scroll around and look at complicated stuff. This is just helping us a little bit. Is there anything else we could do? Not really. I mean, in each case here, we need writer to be an independent thing. There might be a temptation on some people's part to make this a member, but you're just, by making it a member, you're really only saving that much code. The declaration, the type declaration portion, because in every case, you're going to have to reset this thing. So that kind of makes unnecessary work. So I think I would probably just leave it here, right? I have a thorough exercise of things. I have nice, clean, simple functions over here. Apparently I accidentally imported netmime when I didn't need it. Let's run all of our tests, make sure everything's happy. We're getting a prettier type warning over here. Let's see. This field can be made read-only. Well, sure, we could, I guess, make that read-only. I don't know. I don't know that that gets us anything other than preventing us from accidentally overwriting it. We are going to run into an interesting situation that in real life, in production, because of this constructor, we're going to be required to pass in a text writer of some kind, like console write line. What we could potentially do to help our user, right, is something that looks like public FizzBuzz generator, no arguments, and then say call myself. So FizzBuzz generator console write line console. Yeah, because I got system IO in here. Yeah. All right. Or just, I guess you could just do this. I don't even need to call the other constructor, just do that. How would I do that? I'll have to look that up. Don't remember. But basically what we've said is you now have to pass a text writer in here every time. So you pass console console write line in as the writer. Oh, there it dawned on me. I was trying to pass the write line method because I wasn't thinking out loud. So you could probably do something like that as a convenience, right? And then you get into well, how do I test that? This technique down here of injecting this is called dependency injection. I depend upon some kind of text writer, so you need to inject it into me. If you just write all of your code that way, you never get stuck with a function like this where you're like, well, how do I do that? However, you may find this convenient. You may find ways to validate that this is in fact correct. That's a subject for another presentation. All right, cool. So I'm going to check that in. Git status, git commit -a -m, add testing for play method. All right, cool. Well, thank you for watching. I'll post this to YouTube in a little bit with links and an updated README, but I need some time to go through and create all the setup instructions, and I just wanted to get this published as soon as I could. Have a good evening.